channel Edu9. Here the problem is A is prime to B, that is GCD of A and B will be 1. Then we are asked to prove that A plus B is prime to AB and also A square is prime to B square. For the first part, since A is prime to B, therefore it is clear that GCD of these two integers, that is A and B, must be equal to 1. Then from the property of GCD, that is greatest common divisor, we can find out two integers u and v satisfying the result AU plus BV equal to 1. Now we are going to prove A plus B is prime to AB. For that we have done this is as a balance where minus AB plus AB is introduced, that is ultimately 0, and taking a common we can obtain A into U minus V plus A plus B into V. From this relation it is clear that U minus V and V both are integers. From this result we can state that the GCD of A and GCD of A and A plus B must be equal to 1, which implies that A is prime to A plus B. And the next target is we have to prove A square is prime to B square. For that, initially we are going to prove that A square is prime to B. Then we are going to establish that A square will be prime to B square also. Now, the result AU plus BV equal to 1 can be written as AU equal to 1 minus BV. We are squaring both sides, which implies that AU whole square means A square U square, and the whole square of 1 minus BV implies 1 minus 2BV plus B square V square. Here we took these terms in the left hand side and taking common B we get this one. Clearly U square is an integer, also 2V minus BV square is also an integer. From this line we can state that A square and B are prime to each other. We suppose U square equal to M and 2B minus BV square equal to M. This is a substitution simply. Then we get A square M plus Bn equal to 1. From that Bn equal to this, and again squaring in the both side we got this result, and these terms are taken in the left hand side and taking common as A square we obtain A square into this and plus B square into N square, where the value 2M minus A square M square is an integer. Since M is an integer, 2 is an integer, A square M square all are integers, so the addition, multiplication, subtraction of integers always implies an integer. This implies that the total value 2m minus a square n square, this is an integer, n square is an integer. This implies a square and b square are prime to each other because the GCD of a square and b square will be 1. So our result is. Next problem is if A is prime to B, that means ultimately GCD of A and B equal to 1. Now we have to prove that GCD of A plus B and A square minus AB plus B square is either 1 or 3. Now we consider that GCD of these two values is D. Then D as greatest common divisor, it must divide these two elements. So D divides A plus B and D divides A square minus AB plus B square. We all know that if D is the GCD of any two integers, then if xy be any integer, D must divide ax plus by. From that we can state that D also can divide A plus B into A plus B. That is, here the value of ax is A plus B, that is A plus B is multiplied by again A plus B, and A square minus AB plus B square is multiplied by the integer minus 1. This implies that D divides 3AB, and D divides 3AB is an important result. Clearly d divides a plus b and d divides 3ab. D divides a plus b from that and d divides 3ab. Also we have GCD of AB equal to 1, and from that we can also conclude that GCD of A plus B and AB equal to 1. Now we can find out two integers u and v such that A plus B into u and AB into v equal to 1. Thus D divides A plus B. Why? This is the assumption. D divides A plus B. So from the definition of divisibility of integer, we can find out an integer p such that A plus B equal to dp. Why? We know that if d can divide A plus B, then we can find out a quotient and the remainder will be 0. From that we can conclude A plus B equal to d into p plus 0 by the division algorithm. So A plus B must be equal to d into p. That is why A plus B is taken as dp. For some integer p belongs to z. Also upd plus bab. From where? In this result, if we substitute the value of A plus B as dp, then we get dpu plus vab equal to 1. From this result, we can see that up is an integer and v is an integer. Therefore, the GCD of d and ab must be equal to 1. Since GCD of d and ab equal to 1, and we have d divides 3ab, therefore d will never be a factor of ab, hence d must divide 3. This is our conclusion. If d divides 3, we all know that 3 is a prime number. Again, d is also a positive number. Then if d divides 3, then there is only two possibility, either d equal to 1 or d equal to 3. So since the values of d are either 1 or 3, therefore the assumption was d was the GCD of these two. So GCD of A plus B and A square minus AB plus B square is either 1 or 3. Hence the result is established.